In this class, we're going to talk about chi-squared. Before we have any calculation, let's understand what is meant by this concept, chi-squared. Chi-squared refers to a test of statistical significance. It helps to determine whether a systematic relationship exists between two variables or not. Now, when we talk about chi-squared measure the deviation that exists between two variables. You understand? That is the simple analogy behind this concept. Are you paying attention? Okay, so there are two conditions that I want you to know. Okay, there are two conditions that I want you to know. This is a typical representation of chi-squared. You see, this one means calculated chi-squared. You understand? Are you paying attention? This is the symbol for calculated chi-squared. Calculated chi-squared. Are you paying attention? Now you will have something like this. This is what we call tabulated chi-squared. Tabulated chi-squared. This one is given on the table. You understand? Don't worry, I'm going to explain. Okay, so I just gave you the symbol. Now the reason why I bring this out is because there are two conditions that I want you to understand as far as this topic is concerned. Okay, the first condition is that if the calculated chi-squared is equals to 0, are you paying attention? If the calculated chi-squared is equals to 0, this implies that the observed and the expected frequency agree. That is, there is no deviation. You understand? That means there is relationship between the observed and the expected frequency. There is relationship between the variable that we are dealing with. You understand? You know, chi-square tells us the differences or the relationship that exists between two variables. Okay. Now, if the value of calculated chi-squared, you understand? Listen. If x squared c is equals to 0, this implies that there is no deviation. You understand? There is no deviation between the expected and the observed frequency. Okay, there is no deviation between the observed and the expected frequency. Now, another condition is that if the calculated chi-squared, that is x squared, okay, let me just put it, x squared is equals to, okay, is greater than 0. This implies that there is deviation. You understand? Are you paying attention? There is greater discrepancy. That is, there is inconsistent. There is deviation between the observed and the expected frequency. Now, mathematically, chi-squared can be expressed as this. You know, now I'm talking about the calculated chi-squared. Don't forget that I told you the tabulated chi-squared is given on the table. You understand? And it might even be given in the question. Are you paying attention? So now, to determine the calculated chi-squared, the calculated chi-squared is given by this formula: summation of the difference between the observed and the expected frequency all over the expected. You understand? This is the formula. You understand? The difference of the square of the observed and the expected frequency divided by the expected frequency, their summation will give us the calculated chi-squared. Do you understand? Okay. Now, before we delve into work example, I'm just giving you the concept. I'm giving you the concept because all these are important so that you will not, so as for you to understand some terms that we're going to be talking about when we're dealing with the calculation. Okay, so that is the formula for chi-squared. Okay, another important thing that I want you to understand is the degree of freedom. You understand? What do we mean by degree of freedom in chi-squared? The degree of freedom tells how much freedom the data has to vary while still meeting certain condition. That is the simplest definition of degree of freedom. You see, I'm going to explain. In statistics, we have two degrees of freedom depending on the chi-square test. Are you paying attention? In statistics, we have two degrees of freedom depending on the chi-square test. You know, the type of chi-square test that we're dealing with will tell us the degree of freedom that we're going to use. You understand? Now, there are two tests in chi-squared. Number one, the goodness of fit test. Hello, there are two tests in chi-squared. In chi-squared, the first test is the goodness of fit test, and the second test is the test of independence. You understand? Each of these tests uses different sets. You understand? This makes the degree of freedom to be different. You see, we're going to have work example on each test. You understand? So you just have to pay attention, okay? Just be putting the notes down, okay? Now, each of the tests uses different set. That is, there is something called contingency table. We are still coming there. Each of these tests uses different sets, which makes the degree of freedom to be different. Now, the goodness of fit test, I want to explain that now. The goodness of fit test is used to compare observed data to expected data for one variable. You can see now. Now, so if we have a chi-square in which we have only a single variable, that means that this chi-square test is for the goodness of fit test because we are only having a single variable. You understand? So when you are given a question and you are asked, what type of test is this? Look at the variable that you have. Example is a die. You can be given you can be working on a die. You can be working on a die, and you are asked to test for this so things. This the type of chi-square is goodness of fit test. You understand? Because we are only having one variable. Okay. Now, that is all about goodness of fit test. For the goodness of fit test, the degree of freedom is n-1 because we are only having one variable. Hello. The goodness of fit test, the degree of freedom for the goodness of fit test is n-1. You see, the reason why I'm giving you this explanation is because all these are important in your calculation. You understand? If you didn't understand this concept, you won't be able to comprehend the calculation itself. Okay? So, when you are dealing with goodness of fit test, which involve one variable, a chi-square test that involve one variable is known as goodness of fit test. So when you're dealing with that type of chi-square, the degree of freedom is n-1. Okay. Now, the test for independence is used to check if two variables are related using a contingency table. Okay. I'm very sure if not, you will have come across some table like this on a chi-square. You will have something like this. Where you're going to have one variable here. Okay, you can have one variable, the first variable, the second variable, x1, x2, x3, y1, y2, y3. You understand? Now they are not going to be you are going to be asked maybe this variable 1 and variable 2 are related with respect to all these subsets that you are given. You understand? Don't worry. Okay, all you have to do is just to pay attention. Okay. So this is a typical representation of the contingency table. You understand? So when we are dealing with test for independence, the test for independence tells maybe there is relationship between two variables. On a contingency table, we have two variables, which are variable 1 and variable 2. You understand? So chi-square test, we have more than one variable. You understand? In this type of chi-square test, that is for test for independence. You understand? That type of chi-square, there is more than one variable, and the goal is to determine how the variables that we have are related. Okay, let me quickly explain what is meant by contingency table. Don't forget that this is a typical representation of contingency table. You see, all these cells will contain some values. You understand? Okay, so a contingency table is a table used to organize and summarize data to show the relationship between two categorically variables. You understand? Okay, a contingency table refers to a table used to organize and summarize data to show the relationship that exists between two categorically variables. You see, a contingency table is characterized by row and column. You see, variable 2 belongs to row. You understand? This is for row 1, y1 is for row 1, y2 is row 2, and y3 is row 3. You understand? And variable 1 is on the column. The first column is for x1, which is under variable 1. You understand? The second column is x2, the third column is x3. You understand? I'm just trying to explain what you have on the board. Okay, so a contingency table is characterized by row and column, where each row represents the categories of one variable and each column represents the categories of another variable. You can see. Okay, now another thing that I want you to understand Another concept that I want you to understand before we delve into calculation is the hypothesis. You understand? Hypothesis. We have known hypothesis and alternative hypothesis. You understand? Hypothesis refers to a statement about the relationship in independence, relationship or independence in the data set. Let me just put it like that. Okay. Hypothesis refers to a statement about the relationship or independence in the data set. For example, you can, okay, let's use this contingency table. We have two categorically variables, which are variable 1 and variable 2. Variable 2. You understand? Now, in this, the goals of this is to determine whether there is a relationship or independence. You understand? If there is a relationship, that means that one variable depends on the other. That is, the effect of one variable affects the other. Now, if it is independent, that is, there is no relationship. You understand? So now, if you can see, the goals of this is to determine whether there is a relationship. Now, there is something called hypothesis. Hypothesis is a statement. You understand? Hello? Hypothesis is a statement about the relationship, you understand, that exists between our data set. Now, hypothesis is just like assumption, you understand? It's a statement of assumption that you make about a situation or a relationship, you understand? And it is tested through research or analysis and others like that, okay? Now, in chi-squared, pay attention. In chi-squared, the hypothesis is to test whether there is no effect or there is effect on the relationship between the variable that we have on the contingency table, like I've already explained before. Okay? Now, let me give you the two hypotheses in chi-squared. The first hypothesis is null hypothesis. Null hypothesis. Null hypothesis is usually represented by these signs, H naught. Okay? H naught. Now, when we are talking about null hypothesis, in this hypothesis, the assumption is that there is no effect or relationship between our variable. You understand? Hello? Don't forget that I explained what is meant by hypothesis. It's just like a statement. You are going to see all this as we delve into calculation, okay? Hypothesis is just like a statement. Now, a statement whether there is a relationship or there is no relationship. Now, we are talking about the hypothesis that we have in a chi-squared, and the first hypothesis is null hypothesis, which is represented by H naught. Now, in this hypothesis, the assumption is that there is no effect or relationship between our variable. Example, let's say we want to study the effect that gender has on I'm just looking at on voting preferences. Okay, now let's say we want to study the effect that gender has on voting preferences. If it is null hypothesis, the gender will have no effect on voting preferences. Hello? If the hypothesis is null, okay, another question arises in your heart. You are trying to ask me that, how do we know maybe we have null hypothesis or we have the second hypothesis, which I'm going to discuss as well in this video. You want to ask me? Yeah, don't worry, we are still coming there. I'm just trying to explain what is meant by null hypothesis right now, okay? In null hypothesis, the assumption is that there is no relationship. For example, I gave you an example just now. Let's say we want to determine the relationship, we want to test maybe gender has effects on voting preferences. You understand? Now, in null hypothesis, the gender will have no effect. You understand? Because the assumption is that there is no effect in the relationship in the categorically variable that we are dealing with in our there is no effect between the categorical variable that we're dealing with in our chi-square test. You understand? So gender will have no effect in null hypothesis. Don't worry, I'm still going to explain how you are going to know maybe this is null hypothesis when we accept or reject. You understand? Now, the second hypothesis that we're going to talk about is the alternative hypothesis. Okay? Alternative hypothesis. In alternative hypothesis, okay, let me just give you the symbol. Alternative hypothesis is represented by this. You understand? HA. Alternative hypothesis. Alternative hypothesis, in this hypothesis, the assumption is that there is a relationship or effect between the variable being studied. You understand? If we use the same example between gender and voting preferences, in alternative hypothesis, the assumption is that there is a relationship between them. That is, gender has effect on voting preferences. That is, gender determines the person that the populace want to vote for. So that is the effect. You understand? So that is for alternative hypothesis. Okay. Now, having explained the concept, I'm very sure you understood all this. Now let us go into work example. Okay. I want to write the question down. Find out whether anxiety and social interaction are related given the contingency table below. We have the anxiety in the column side, we have the no, low, medium, and high, and we have the interaction on the horizontal side. We have the interaction and no interaction. We are given that the critical value at 3 degrees of freedom and 5% level of significance is 7.82. Okay, so how do we go about this question? To watch the solution to this question, kindly check the description of this video. You know, this is the first class. You can check the second class in the description of this video to watch the solution. Okay, before you go, please don't forget to like and share this video. Okay, and to be part of this channel, you can consider subscribing, but it is very compulsory that you like and share the video. Okay, see you in the next class.